So the vertex form, guess what it tells us? It tells us the vertex. I always start with the axis of symmetry because it's just as easy. It's just one number. But it should be super simple, easy look and know. Don't forget, we do know how it opens. If the A is positive, it opens up. If the A is negative, it opens down. Axis of symmetry is always going to be whatever x equals h is. So whatever that h value is, that's where your axis of symmetry is. Don't forget about the sign change. If you see minus h, your h value is positive. If you see a plus h, your h value is negative. Your vertex then is going to be at hk. So when you come down here to look at this, your axis of symmetry is it's x equals h. So let's write this down. H is 1, A is 2. Let me not get those mixed up. A is 2, H is 1, and K is 3. So the axis of symmetry is x equals 1. That means that this one is going to have an axis of symmetry right there at the x equals 1 line. The vertex is at HK, 1, 3. So we know it's at 1, 3. And we also know that it opens up. So it's going to be opening up like this. We also know that this 2 is also a transformation. Don't forget that these are still A, H, and K values. They still cause the same transformations. So when we get to the transformation part, that should be pretty easy for us to do. What else? This is the look and know information, but we really remember we need 3 points to be able to graph a nice parabola, and right now we just have 1. But we do have in the small calculation category, we can easily calculate the y-intercept. Remember, the y-intercept is the value when you plug in 0 for x. So that's how you're going to calculate your y-intercept. You're going to take your equation that they give you over here and you're plug in 0 for x. So to find your y-intercept, you're going to take 2, plug in 0 for x, and then calculate that. So you're going to have to follow the order of operations. The order of operations say that you do parentheses first. So 0 minus 1 is negative 1. Negative 1 squared is negative 1 times negative 1. That's a positive 1. Positive 1 times 2 is 2. I do these in steps. So that becomes negative 1 squared plus 3. That becomes 2 times 1 plus 3, and that becomes 2 plus 3, and that becomes 5. So that means I have a y-intercept at 5. So my y-intercept, you probably want to write it as an ordered pair. It's 0, 5. And don't forget, we now can find the mirror image. The y-intercept is 1 unit away from the axis of symmetry, so on the left side, so go to 1 unit away on the right side. There's the mirror image, and now you get your parabola. Now that you have the parabola drawn, you can go back and answer questions about interval of increase, interval of decrease, domain, range, all those questions. All right, the last one is factored form. The factored form, again, by looking at A, tells you, oh, I didn't write it down up here. Let's do plug 0 in for x and calculate y. Okay. So for this factored form, the A tells you how it's open. If it's a positive A, it's opening up. If it's a negative A, it's opening down. And these two values, this P and Q, those are your roots. Your roots are x is it's gonna cross the x-axis at x equals p and x equals q. So notice again, it's kind of works like h. When you see a minus, when you see the minus right here, the minus p, this minus p means that the value of p is actually a positive. So that's going to see down here, we're going to be able to look at this and say, okay, it's crossing my x-axis, my roots, or you want to write down x-intercepts or whatever your solutions. Your roots are x equals 2, because your p is 2, and x is equal to negative 3. Again, because the formula up here says minus. This formula says minus, so if we see a plus, that means it's really, what we're seeing right here is x minus a negative 3. And so when we see a plus sign, it's really minus a negative. So the value of that Q right there is 3. And by the way, there's nothing special about P and Q. Some people put A and B right there. Some people put R1 and R2 to stand for roots. It doesn't matter. The P and Q is just, I think, more used than some of the other ones, but don't get caught up on the P and the Q. It could be another letter that you see there. It just means that it's the roots. So what that means is over here on the x-axis, I know that I'm crossing the x-axis at 2, and I'm crossing the x-axis at negative 3. That's what I know so far. Now, if you'll notice, there's a quick calculation up here for you to find the axis of symmetry. The axis of symmetry is always going to be the average of those two x values, because what do we want? We want the number in the middle. How far apart are those two numbers? We'll figure out how far apart they are. They are, let's just count. 1, 2, 3, 4, 5. They are 5 units apart. So the axis of symmetry is going to be the point that's halfway between those two. So take 5, divide it by 2, you get 2.5. If you average these two numbers together, add them together, and divide by 2, you will get the exact value. So 2 plus a negative 3 is negative 1. Negative 1 divided by 2, that's going to give me negative 0.5. So my equation for the axis of symmetry is x equals negative 0.5. There's negative 0.5. So right between 0 and 1 is my axis of symmetry. Okay, now remember the axis of symmetry. What did I do? I did P plus Q divided by 2. And then my vertex, I'm going to do the same thing for this vertex that I did for the other one. I've already got half of the vertex. I already know the vertex is going to be somewhere on this line. I just have to know where. I do know it's opening up, so it's got to be somewhere below these two values, because that way it opens up. And all I got to do to figure out where it is take this number right here and plug it in. And don't be afraid to use a calculator. So I'm going to plug in negative 0.5 minus 2, and then I'm going to multiply that times negative 0.5 plus 3. So take away a half from negative, no, add a half. So that's negative 2.5 times, that's also negative 2.5. No, it's a positive 2.5. The 3 is bigger, so it's a positive 2.5. And I'm going to have to use my calculator, but I think that's going to come out. I know it's going to come out to be a negative. I think it comes out to be 6.25. Multiply those on the calculator. So that means that my vertex is at negative 0.5, comma, negative 6.25. So there's the 0.5, and then go down to negative 6. It's somewhere right down there. Now you've got some values. Connect the dots, and now you can go back and answer all of those questions about intervals of increase, intervals of decrease, domain, range, all of those things that we talked about when we had the graph. So review those notes and be sure you can answer all of those questions about each one of these equations.